James Webb Space Telescope was built to look back to the very beginning of time, but what it has recently discovered has deeply unsettled the scientific community. Far into the infrared spectrum, Webb detected a series of large, glowing red objects that should not exist. These are not simply stars. They are fully formed, massive galaxies appearing at a time when the universe was expected to be a chaotic, dark, cosmic soup. According to the standard model of cosmology, galaxies require billions of years to accumulate mass and develop structure. Yet these so-called universe breakers appear mature and filled with old stars just 300 million years after the Big Bang. It is the cosmic equivalent of discovering a modern skyscraper standing in the middle of a prehistoric jungle. To understand why this is considered impossible, we must look back to the cosmic dark ages. This was the period after the Big Bang, when the universe contained nothing but neutral hydrogen gas. There was no light, and certainly no massive spiral galaxies like the ones Webb is now observing. Gravitational theory suggests that stars form slowly from small clumps of gas. It takes eons for these clusters to merge into gigantic cosmic cities. Yet Webb's data shows that these cities were already highly developed when the universe was still in its infancy. This gap in our understanding is what astronomers refer to as the redshift crisis. When the first images reached Earth, researchers initially suspected a calibration error in Webb's sensors. These small red dots were far too bright and far too massive for their age. Early estimates suggested that they contain as much mass as our entire Milky Way galaxy. How could a galaxy grow so large in such a short amount of time? Some theoretical experts believe that the early universe was far more efficient at forming stars than it is today. The density of these objects is astonishing, indicating that stars were packed together up to 1,000 times more tightly than in our current galactic environment. One radical theory involves the existence of dark stars. These are not stars powered by nuclear fusion like our Sun, but by dark matter instead. If dark stars existed in the early universe, they could have grown millions of times larger and brighter than any stars we have ever observed. If these seemingly impossible galaxies are actually composed of dark stars, it would explain their enormous size and mass. These dark stars would act as cosmic seeds, allowing galaxies to bypass millions of years of slow evolution. This would mean that dark matter is not merely a ghost, but the primary architect of our universe. For nearly a century, the Big Bang theory has stood as the untouchable foundation of modern astronomy. It tells us that the universe is 13.8 billion years old. But if Webb has truly detected mature galaxies so early in the cosmic timeline, then the mathematics behind this model begins to fail. Some scientists are now daring to suggest that the universe may be twice as old as we currently believe, around 26 billion years. If true, this would give these galaxies enough time to grow and evolve. However, changing the age of the universe would mean rewriting nearly every physics textbook ever written. Behind the light of these seemingly impossible galaxies lies a profound secret: supermassive black holes. The latest data from Webb reveals that gigantic black holes already existed almost immediately after the Big Bang. These objects, known as heavy seeds, act like cosmic magnets, forcing gas and dust to form galaxies far faster than we ever imagined. This represents one of the greatest paradigm shifts in the history of astronomy. If black holes formed before stars, then our textbooks are fundamentally wrong. But if black holes are not the answer, then the problem lies with gravity itself. Theories such as modified Newtonian dynamics, MOND, suggest that gravity may have been more sticky in the early universe, allowing matter to clump together in ways that challenge Einstein's theory of relativity. NASA is now racing against time. If follow-up observations detect elements such as oxygen and carbon within these galaxies, the 13.8 billion year age of the universe could collapse overnight. We are no longer just observing the past. We are witnessing the birth of a new science. The laws of physics may be breaking, but that is where true understanding begins. The universe is calling, and we are only just starting to listen.